In this lesson, we will discuss extraction of iron by reduction. Iron is the most abundant metal ore in the Earth's crust. The main ore of iron are hematite, magnetite, limonite, siderite, and iron pyrite. All these ores, with the exception of pyrite, are used in extraction of iron. Iron pyrite is used in manufacture of sulfuric acid because sulfur impurities affect the properties of steel. The ore is crushed and heated to remove water and other impurities with low melting point, leaving behind 30 to 90% iron 3 oxide. The impurity present after are silica and alumina as the main impurities. Reduction of iron 3 oxide is carried out in a blast furnace. A blast furnace is a huge structure more than 30 meters tall, constructed of steel plates with heat-resisting bricks.
The blast furnace is primarily used for the extraction of iron, lead, and copper. It is a gigantic steel tank which is internally lined by fire bricks that are resistant to temperatures of up to 2000 degrees Celsius. While extracting iron, its ore, along with limestone and a reducing agent, namely coke, are placed inside the topmost part of the furnace. Air which has been heated at about 1000 degrees Celsius is blown into the bottommost part of the furnace from small openings called tuyers. This hot air blast burns the coke and also maintains the high temperature needed to reduce the ore to iron, which sinks to the bottom of the furnace. On the other hand, impurities called slag float on the top as they are lighter than iron. Slag is drained through a pipe placed at the lower part of the blast furnace, whereas iron is drained into sand molds to harden. This form of iron is known as pig iron or cast iron, which is processed further. The carbon content from the cast iron is reduced to produce various grades of steel.
The coke burns in the hot compressed air to form carbon 4 oxide gas. This reaction is highly exothermic and it raises the temperature to between 600 to 1600 degrees Celsius. The carbon 4 oxide gas raises up and reacts with more coke or carbon, which reduces it to carbon 2 oxide, that is endothermic reaction. The carbon 2 oxide acts as reducing agent. The carbon 2 oxide formed reduces the iron 3 oxide to iron. This reaction takes place at the upper part of the furnace at temperature about 600 to 700 degrees Celsius. Iron produced settles to the bottom of the furnace and melts at 1539 degrees Celsius. The limestone helps in removal of impurities, especially silica dioxide and other acidic impurities in the ore to form liquid slag. At 800 degrees Celsius, the limestone decomposes calcium oxide and carbon 4 oxide. The carbon 2 oxide formed after calcium carbonate decomposes is reduced by the coke to produce more carbon 2 oxide, which reduces more of the iron ore. The calcium oxide with the other impurities to form slag. The molten slag is less dense and floats on top of molten iron, preventing reoxidation of the iron to iron 3 oxide by the hot air in the furnace. The iron obtained from the furnace is about 90 to 95% pure and it's called cast iron or pig iron. It contains the following impurities: carbon, sulfur, manganese, sulfur silicon, and phosphorus. The impurities makes it brittle and cannot be welded. It's used to make cookers, stove railings, water pipes, and not materials that require strength, for example, bridges. Impurities in the iron are removed by oxidation. Wrought iron is the purest form of commercial iron and contains 99% of iron with only 0.1% carbon. It's not brittle like cast iron and can be welded and shaped by hammering when hot. It's malleable and ductile. Most of the iron produced is converted to steel, which is an alloy iron. An alloy is a uniform mixture of a metal with one or more other substances. For example, steel is an alloy of iron with carbon, chromium, and manganese. Majority of the iron produced in the blast furnace is converted into different steel alloys. The common alloys with some of their uses are given in the table below. The main pollutants are carbon 4 oxide and sulfur 4 oxide.